Project code ITPS08. Project title: a single input variable fuselage control for DFIG based wind power generation system in standalone mode. The DFIG having the two-side excited, actually doubly excited system. So in general induction motor having stator and rotor side. Rotor side, here it is stator side. So it have capable of compensate or eliminate the harmonics or unbalanced load compensation. All the thing it will be done using this voltage source inverter with the converter, at least stator side converter and the rotor side converter having the compensation ability. It is a advantage of DFIG. In existing concept, for the voltage source inverter side and the voltage source converter side, the both back-to-back converter, having in between capacitor is there from stator to rotor. Okay, here having six switches, here also having six switches. We have to control the switches, then only we can achieve the compensation output. For the unbalanced load, we can get the undistorted or correct output. So we can, in conventional normal PWM control or other technical use, but in existing concept, the using the physiology control. Before that, physiology control having the three black. First is input membership function, then conditions, and output membership function. So in existing concept, dual input variable used. Actually, two input is given and the output, single output will be obtained. So again, other two input is given, single output is getting. So we can, the four input will be given. So the conditions also increased. This output for P, this output for I. This PI only given to the PWM. Okay, here the conditions is based on the input. So in a existing concept, due to the dual input variable having number of conditions, so it increased the computation burden. So existing concept high computation burden because of the double input variable in first logic control. In proposed concept, single input variable. Here conditions, single input, it can capable of getting the two output. Only you have only using the five conditions. Within the five conditions, you get the output like P and I. So for this DFIG system, we can use the single input variable. It reduces the computation burden. So it is a black diagram. DFIG is directly given to the grid. In one side is a rotor side converter, other side is grid side converter. Here the facility controller to control the rotor side and grid side converter. Application for the wind energy conversion system, motor drive, and a grid connector system. Software mainly used to implement this simulation using MATLAB 2015B version, and the microprocessor lab is used to give the program to PIC microcontroller, because in hardware prototype we are using the PIC microcontroller, so we have to give the program using microprocessor lab. It will PIC microcontroller generate the pulse for the rotor side and stator side converter. These are all the minimum hardware requirement, like power MOSFET, transformer to excite the PIC microcontroller, and other active and passive elements are used. Thank you.